Hello guys, in today's lesson, we are going to be looking at worked examples on balancing of redox equation. In our previous class, we looked at everything on redox equation. We looked at the various situations that can bring about redox equations and redox reactions. So today we are looking at how to balance, a couple of redox equations. So first of all, let's look at the various kinds of equations that we have under the redox equation. So we talk about redox equation. We have two major kinds of redox equation. We could have simple redox. Sometimes the redox equation could be called ionic, simple redox, or ionic equation. And we could also have the complex redox equation. So you have the simple redox equation and the complex redox equation. So under the complex redox equation, we have two major equations under it. We have the acidic redox equation, and then we have the alkaline redox equation. So we have the acidic redox equation, that's under the complex redox equation, and we have the alkaline redox equation under the complex redox equation. Now, for the simple redox equation, we mainly use a method known as the half cell. We use the half cell method. That's the method we use to solve this. Why for this? For the complex, we use the ion electron. We use the ion electron method. So the half cell method and the ion electron method, they are the same. But for this, it's just a bit tweaked to be able to handle the acidic and the alkaline complex redox equations. So we're going to be looking at the first worked example. Okay, guys, let's look at the very first question on the board. Now, balance Mg, that's solid, magnesium is a solid, plus hydrogen aqueous equals to magnesium aqueous plus hydrogen gas. Now, how do we know if this equation is balanced or not? So what are the things you have to watch out for to know if you have a balanced equation or not? Don't forget, this is not a non-redox equation. This is not, like the set of ones we did in our previous lessons. This is redox. We're talking about redox equation. We're talking about redox, it means there's reduction on one end and there's also oxidation on one end. Now, don't forget, in our previous lesson, we said one of the ways we get to know if we have a redox or not is simply this. When you look at the redox equation, for a redox equation, for oxidation, reaction, there is an increment in oxidation number, and for reduction, there is a reduction in oxidation number also. So that's the format we're going to be using. And don't forget, we're working on simple redox equations this time around. We're not talking about complex. The complex we discussed in the next couple of lessons. So this is simple. So how do we know it's simple? It is simple because of the fact that there is no attachment. When you look at this magnesium, there is no oxygen attached to this magnesium. For the complex ones, either acidic or alkaline, oxygen is attached to either a metal or to a non-metal. But this is just purely, as you can see, no oxygen is present. Just magnesium, hydrogen, and we have the same set on the other side of the product. So how do we know the oxidation number? That's the first thing. That's the first question you're going to ask yourself. How do I get to know what's the oxidation number for magnesium, for this hydrogen aqueous, for this, and for this? Now, the fact is this: when you have an atom of an element, no matter the amount of atoms of the element, let's say if I have 10 atoms of sulfur, what is the oxidation number for this S10, for this 10 atoms of sulfur? The oxidation number is equals to 0. Now, as we said in our previous lesson, when you look at a given atom of an element, the oxidation number is always 0 until that very element, has a communication with another atom of an element. So regardless of the amount of atom, if it's S100, S whatever, S5, S8, the oxidation number is always going to be 0 until there is a communication between this and another atom of an element, of another element. So if I have SO2, for example, what is the oxidation number of sulfur here? Don't forget that this is not just ordinary sulfur like S10. For S10, oxidation number is 0, but SO2, sulfur now has a relationship with two atoms of oxygen. Now, what's the charge? The charge of SO2 here is 0. There's no charge on this. So don't forget, we worked on oxidation numbers and valencies in our previous lesson. So how do I get the oxidation number of this? One atom of sulfur, just one sulfur, plus oxidation number for oxygen is -2. -2 times 2 equals to the charge is 0. So S plus -4 equals to 0. So this crosses. The oxidation number of sulfur is plus 4. As simple as that. While oxygen is minus 2. But here, oxidation number for sulfur is absolute 0. Why? Because it doesn't have a relationship with any other thing. Now, another way we can get to know oxidation number for a given atom of an element, like when you look at magnesium here, 2 plus, hydrogen here, that's H plus, is different from just ordinary sulfur, which is S10. These ones, they have a plus or they have a minus. So when you have a given atom of an element with a positive sign or negative sign, it simply means that very atom of an element has already communicated with another atom of an element. And that's why we have a residue plus or minus. Like H plus, this is electropositive, this is electropositive. So when you have Mg2 plus, it means these give out 2 electrons to become electropositive, that's plus 2. While this give out 1 electron to become electropositive also. So as simple as that. So this has a communication with another atom of element. It's easy to get the oxidation number. If it's not this or this, then oxidation number is 0. So magnesium, oxidation number of magnesium is 0. Why? Because it doesn't have any relationship. It's not magnesium chloride, just ordinary magnesium. Why hydrogen here, oxidation number of hydrogen here is plus 1. This is plus 1 here because we have a plus 1. It means it gave out an electron. Magnesium here also is plus 2. We have 2 plus. While hydrogen here is 0. So we have 0 here, plus 1 here, plus 2 here, and 0. So we are talking about simple redox equation. Don't forget, that's what we are discussing. So first of all, we've gotten our oxidation numbers. Magnesium here on the reactant 0, hydrogen plus 1, magnesium here plus 2, hydrogen here 0. So when you look at this, oxidation number 0 from here increased to plus 2. So increment in oxidation number, like what we discussed in our previous class, is what we call oxidation. So this is oxidation, OX. Y plus 1 reduced to 0. This is reduction. This is reduction. So when it comes to using the half-cell method, you are going to solve this, like we're solving simultaneous equation. But first of all, let's analyze what happened here. How come the 0 moved from 0 to plus 2? So magnesium, which is 0, became magnesium 2 plus. So from 0 down to plus 2. So for these to have moved from 0 to plus 2, it means 2 was added to this. So how do we add 2 to this? Or it means this gave out 2 electrons. So the fact is, when a given atom of an element gives out an electron, it becomes electropositive. When it takes in, it becomes electronegative. So this is 0, then this plus 2. It means we have a plus 2 around this place. That means 2 electrons. So how do we add 2 electrons? Let's see how we're going to do that. Mg, and now electron is minus 1 naturally. So for you to add that, you have to minus 2 electron. So that is 0 minus 2 times minus 1, that is plus 2, equals to Mg2 plus. So the next thing you're going to watch out for, let's see how many atoms of magnesium do we have here. We have just 1 atom of magnesium. How many atoms of magnesium on this other side? Also just 1 atom, so they are balanced. So we are done with this very first one. So this Mg, which is 0, 0 minus 2, electron minus 1. 0 minus 2 times minus 1, 0 plus 2, will give us plus 2 on this other side. So this is equation 1. We're done with that. So the next, let's analyze the hydrogen. How did we get to this very point from plus 1 to 0? How did they achieve 0 here? So let's analyze that. H plus aqueous became H2, this plus 1. This is ordinary 0, oxidation number is 0. So for these to move from plus 1 to 0, it means minus 1 it means we subtracted 1 from this. So that means there's a minus 1. So how do we explain that? So if there's a minus 1, that will be H plus. Now for us to remove an electron, it has to be plus 1 electron, because electron naturally on its own is minus. Electron is minus 1. So if you minus an electron, that will be minus 1, that is plus 1. So for you to minus 1, you have to add that electron to it to get that result. So we have H2 here. That makes it become 0. That's why there's no charge on it. It's just 0, neutral. So when you look at this, this is 2 atoms here on the side. Why this 1 atom? That's one major thing about redox. When it comes to redox reaction, redox involves 2 things. You have to balance the masses. You make sure you balance masses just like non-redox equation. And you also have to balance the electron. So yeah, 1 electron has been added to bring about this. So 2 atoms here, 1 atom here. add 2 to this place to make it become balance. So here naturally 1 electron. So when we have 2 now, it's the 2 electrons. So we have our equation 2. So equation 1, equation 2, we are going to bring them together. We bring them together and solve them simultaneously. That's the next phase of this. So Mg minus 2 electron equals to Mg2 plus, then 2H, that's plus there, that's an aqueous, plus 2 electron equals to H2, which is a gas. So equation 1, equation 2. So what do we solve here? How do we do this? Minus 2 electron plus 2 electron. So for us to eliminate the electron, we have to add up. Very simple. This under mathematics, mathematics equation. So we add up. So what do we have? Mg plus 2H. Now the Mg, which is a solid, plus 2, which this aqueous, don't forget that. This takes out each other. Then Mg, 2 plus, then plus H2, which is a gas. This is an aqueous. So this is our balance redox, equation. So Mg solid plus 2H equals to Mg plus 2. That's 2 plus aqueous plus H2 gas. As simple as that. Okay, guys, we've come to the end of this very lesson. In our next lesson, we'll be taking one more worked example before we're going to be given a couple of take homes to test ourselves. So if you gain 1 or 2 things from this very lesson, I'll love you to subscribe to this very channel at EduMosaic and follow me at Revelation on Facebook. So see you in the next lesson. Thanks and bye for now.